The average distance between Earth and the Sun, about 150 million kilometers or 93 million miles, is known as an astronomical unit. An astronomical unit, AU, is a standard measure used to describe distances in space. Imagine you're trying to measure the exact distance between two cities on opposite sides of the country, but the highways and roads constantly change their paths due to construction. Just like the shifting roads make it hard to pinpoint a consistent distance, the Earth's orbit around the Sun is not a perfect circle, so the distance between them changes slightly throughout the year. The astronomical unit AU serves as a convenient average highway distance, representing the average path or distance, just as you'd calculate an average distance between cities despite varying routes. A large planet made up mostly of gases, like Jupiter or Saturn. Gas giant. A gas giant is a massive planet primarily composed of hydrogen and helium gases. Imagine trying to carry a bag filled with balloons through a windy park. It's challenging because the bag is mostly air, making it light and hard to control. This scenario is similar to a gas giant like Jupiter or Saturn, as these planets are primarily composed of gases, which makes them light and vast, but without a solid surface to stand on. Just as the bag of balloons appears large and voluminous but lacks a solid core, gas giants are massive in size but consist mostly of swirling gases with no solid ground beneath. One of the four rocky planets of the inner solar system, Mercury, Venus, Earth, or Mars, terrestrial planet. A terrestrial planet is a type of planet made mostly of rock and metal with a solid surface. Imagine you're trying to pick the right type of shoe for different activities: running, hiking, or casual walking. Just like how you choose shoes based on the terrain and activity, the inner planets of our solar system, Mercury, Venus, Earth, and Mars, are like the diverse types of shoes, each suited to their own conditions and environments. These terrestrial planets are the rocky shoes of our solar system, each with a solid surface like a shoe sole that supports a specific atmosphere and conditions, much like how shoes support different activities based on their design and material. A body of rock and metal that orbits the Sun. Asteroids are like giant space rocks that travel around the Sun, mainly found between Mars and Jupiter in the asteroid belt. Imagine you're trying to find the perfect spot for your keys in your house so that they're easy to find when you need them. This is similar to how an asteroid finds its spot in the vastness of space, orbiting the Sun just like your keys orbit the central location in your home. Just as you wouldn't leave your keys in a random place, but rather in a designated spot where they can be easily accessed, an asteroid follows a defined path around the Sun, maintaining its position in the cosmic house of our solar system. The fuzzy head of a comet, made of ice and comet dust. Coma. The coma is the glowing cloud surrounding a comet's nucleus when it is close to the Sun. Imagine trying to see through a fogged-up bathroom mirror after a hot shower. Just as the steam and condensation blur your reflection, making everything seem fuzzy and unclear, the coma of a comet creates a similar effect in space. The coma, made of ice and comet dust, surrounds the comet's nucleus like the condensed steam on the mirror, obscuring the solid core and giving it a blurred, fuzzy appearance. A body of ice, rock, and dust that orbits the Sun. A comet is a celestial object that develops a glowing head and tail as it gets closer to the Sun. Imagine trying to juggle multiple tasks at work while keeping everything organized and on track. This scenario is similar to a comet, which is a body composed of ice, rock, and dust that orbits the Sun, maintaining its path amidst the vastness of space. Just as each task, ice, rock, and dust, needs to stay together to form a coherent workflow, the comet, the tasks orbit around your central goal, the Sun, ensuring that everything remains in motion and aligned with your objectives. A streak of light created when a meteoroid is heated by Earth's atmosphere. Meteor. A meteor is a bright trail of light in the sky caused by a space rock burning up as it enters Earth's atmosphere. Imagine trying to run really fast through a crowded room full of people. As you push your way through, the friction and collisions with other people cause you to get hot and sweaty. Similarly, when a meteoroid travels swiftly through the Earth's atmosphere, it collides with air molecules, causing it to heat up and create a bright streak of light. Just as the crowded room generates heat from contact and friction, the atmosphere heats the meteoroid due to the intense friction and collisions, resulting in the meteor's brilliant glow. A meteoroid that lands on the surface of Earth, a moon, or a planet. Meteorite. A meteorite is a space rock that survives its journey through the atmosphere and lands on the surface of a celestial body. Imagine trying to find the lost puzzle piece in a cluttered room filled with various objects. Just like a meteoroid traveling through space, the puzzle piece is navigating through the chaos to find its place on the puzzle's surface. When the puzzle piece finally lands where it belongs, similar to a meteorite, it completes the picture, just as a meteoroid becomes a meteorite when it lands on Earth or another celestial body. A small piece of rock or metal that orbits the sun. Meteoroid. A meteoroid is a tiny object from space that moves around the sun. Imagine you're trying to find a parking spot in a busy supermarket lot, circling around and around, hoping for an opening. Just like a car in a crowded parking area, a meteoroid is a small piece of rock or metal that continuously orbits the sun, waiting for its chance to come close to Earth. In this analogy, the parking lot is like the vastness of space. The car is the meteoroid, and the sun is the supermarket that both guide their paths, illustrating how both are in constant motion, seeking an opportunity to interact with their surroundings. The solid inner core of a comet. Nucleus. In science, a nucleus is the central part of an atom containing protons and neutrons. Imagine trying to find your keys buried under a pile of clothes in your messy room. Just as your keys are hidden beneath layers of clothing, the solid inner core of a comet is surrounded by layers of gas, dust, and ice. In both cases, the essential part, whether it's the keys you need to leave your house or the core of a comet that scientists study, is concealed beneath outer layers that must be navigated or removed to understand or retrieve what's inside. The combining of two nuclei to form a single nucleus, this releases energy. Nuclear fusion. Nuclear fusion is a process where two light atomic nuclei merge to form a heavier nucleus, releasing a large amount of energy, like in the sun. Imagine trying to combine two small balls of dough to make one larger, more robust ball for baking. This is similar to nuclear fusion, where two small atomic nuclei merge to form a single, larger nucleus. Just as combining dough balls can create a larger, more useful piece of dough for your baking needs, when two atomic nuclei combine, they release energy, providing a more stable nucleus, much like creating a perfect dough ball ready for baking. A spot on the sun, which appears darker because it is not as hot as other areas. Sunspot. Sunspots are cooler areas on the sun's surface caused by magnetic activity. Imagine hosting a party where one room feels cooler than the others because the heater isn't working properly. Just like that cooler room, a sunspot on the sun appears darker because it's not as hot as the surrounding areas. In this analogy, the cooler room represents the sunspot. The party is the sun's surface, and the broken heater is like the magnetic field that reduces the temperature, making the sunspot stand out as darker amidst the brighter, hotter surroundings. The region between the orbits of Mars and Jupiter where many asteroids are found. Asteroid belt. The asteroid belt is a vast collection of rocky objects orbiting the Sun between Mars and Jupiter. Imagine trying to find your way through a crowded hallway at school or work, where people are constantly moving in all directions. The asteroid belt is similar to this situation, as it's a busy region in space filled with numerous asteroids moving around between Mars and Jupiter. Just like navigating through a bustling hallway requires careful attention to avoid bumping into others, spacecraft navigating through the asteroid belt must maneuver carefully to avoid collisions with the asteroids, which are like the people moving in that crowded corridor. An ellipse is an oval shape. The orbit of planets are shaped like an ellipse. Ellipse. An ellipse is a stretched circle with two focal points, known as foci. Imagine trying to walk around a crowded room without bumping into anything. Just like you carefully navigate around obstacles, planets follow an elliptical path, avoiding collisions and maintaining harmony in the vast space. In both scenarios, there are main points to focus on. Your path around the room is guided by the most crowded areas, much like how an ellipse is defined by two focal points that shape the planet's orbit, ensuring it stays in a smooth, predictable path without straying. A flat, thin disk of ice and rock particles that orbit a planet, like Saturn. Rings are collections of small particles in space that circle around planets due to gravity. Imagine trying to keep your living room tidy when you have a pile of books that never seems to stay in one place. This is similar to how the particles in Saturn's rings can't settle and instead continuously circle the planet, creating a beautiful but chaotic arrangement. Just as the books form a messy ring around your coffee table, the ice and rock particles orbit Saturn in a flat, thin disk, constantly moving and never coming to rest, highlighting the delicate balance and order within apparent chaos. The surface layer of the Sun that gives off light. Photosphere. The photosphere is the part of the Sun we see that emits the sunlight that reaches Earth. Imagine you're trying to find the best way to present yourself for a job interview, ensuring that your appearance and demeanor create the most favorable impression. This situation is similar to how the Sun's photosphere functions as its surface, radiating light and energy that we can see from Earth. Just as your outward appearance and behavior are what people perceive, the photosphere is the Sun's visible layer that emits light, making it the face of the Sun that we observe from our planet. The middle layer of the Sun's atmosphere. Chromosphere. The chromosphere is a layer of the Sun's atmosphere located above the surface, visible during solar eclipses, and it emits a reddish glow due to its hot gases. Imagine you're at a crowded party, trying to get from one side of the room to the other. Just like at a party where you have different layers of groups to navigate through, the Sun's atmosphere is made up of layers, with the chromosphere being the middle one you must pass through between the core party area and the outer entrance. The crowded party with its distinct layers of people is like the Sun's atmosphere, where the chromosphere acts as the middle layer, separating the inner core activities, photosphere, from the outer atmosphere, corona, much like navigating groups to reach your destination. A group of planets and other objects that revolve around a sun, solar system. A solar system is a collection of planets and other celestial bodies orbiting a star. Imagine trying to keep track of all the people moving around you in a busy shopping mall. Just like the way shoppers navigate around a central hub of stores, planets and other celestial objects orbit around the sun in a solar system. In this analogy, the mall represents the solar system, the central hub of stores is the sun, and the shoppers are akin to the planets and other objects, each following its own path, but all revolving around the same central point. A huge reddish loop of plasma that protrudes from the sun's surface. Prominence. In simple terms, a prominence is a large, bright feature extending outward from the sun's surface, usually in a loop shape made of hot gases. Imagine trying to keep a pot of boiling spaghetti from overflowing on your stovetop. Just as the bubbling water and noodles rise and sometimes spill over the edge of the pot, the sun experiences similar eruptions where loops of plasma extend outward. These solar prominences are like those bubbling noodles, both driven by heat and energy trying to escape their boundaries. So, just as you manage the boiling pot to prevent a mess, the sun's magnetic forces contain these plasma loops, though sometimes they arch far into space before falling back. An eruption of gas from the sun's surface that occurs when loops in sunspot regions suddenly connect. Solar flare. It is a sudden, intense burst of radiation from the sun's surface caused by a magnetic energy release. Imagine you're untangling a bunch of tangled wires behind your TV, and just when you think you've got it, they suddenly snap into place, causing an unexpected jolt or spark. This is similar to a solar flare, where tangled magnetic field lines on the sun's surface suddenly reconnect, releasing massive amounts of energy. Just like the tangled wires that store potential energy and suddenly release it as they snap into place, the sun's magnetic fields in sunspot regions can store energy until they suddenly connect and release it as a powerful eruption of gas.